here. Let me share my screen. And you said you'd like to pick back up at from our last lesson on number 21 here. So 21 is the cosine of 45 degrees. That's just a lookup from the table. That's the square root of 2 over 2, or the unit circle, which I prefer you using. It'll be better for you long term on that. 23 sine pi over 3. So if you're looking at that trig cheat sheet, it gives you both the angle in radian and degree. And you don't want to convert to degree and then back to radian. You don't want to do all that. You don't want to go radian, degree back to. It's just a mess. So just try to get comfortable with radian if you can. That's the square root of 3 over 2. That's just the y value. You're just looking that up there. 25 is the tangent of pi over 3. So that's a little more sophisticated. You got to find sine pi over 3, which we just found, over cosine pi over 3, which we just found, is so that's square root of 3 over 2 over 1/2. So that is the square root of 3. Are you still with me, Jack? I'm
still here. I'm watching. Okay, I'm writing it down.
Great, got it.
I'm just munching on something. I'm not sure you want to hear that.
All right, so 27.
Can you roll back up to number 23 real fast?
Yeah, sorry for rushing through that. So let me know when you're ready to pick up on 27.
Oh, fine. I'll write it down as fast as I can. 2, 5, 3. That's root 3 for 25. All right, on the 27. All right.
So 27 is the cosecant of pi over 6. That is the same as 1 over the sine of pi over 6. Mm-hmm. The sine of pi over 6 is a value from the table. It is 30 degrees. It is 1/2. 1 over 1/2 is 2.
Ah, that's simple enough. All right. Let me see how far it wants us.
Yeah, do we go to 29?
Yeah, I think I go up to number 29, and after that on the 33 through 37 on.
All right, so we got cosecant pi over 3. So the cosecant of pi over 3 is 1 over the sine of pi over 3. The sine of pi over 3 is the square root of 3 over 2. So this is 2 over square root of 3. And when you rationalize this, you get 2 square root 3
over 3?
Yeah.
All right.
All right, so up to 33. 33 is to write each expression in terms of its cofunction. I can explain that as we go. So the cotangent of 73, its cofunction is tangent. It's a pretty straightforward rule. You just subtract this number from 90.
All right.
So 90 minus 73 equals 17. The cofunction of sine is cosine.
Wait, 90, minus 73. That looks like 13, my bad.
Yeah, sorry, 73.
All right, so that's just cotangent of 73 equals tangent of 17. All right, that makes sense. On to number 35. And we got sine of 38.
So the cofunction is cosine, and if you're wondering where I'm getting this, if you have that trig cheat sheet, it's on I think the second page. The second page, bottom right. It has it in radians, but it's 90 minus. It's either 90 minus the angle or pi over 2 minus the angle, whichever way you're doing it.
It's still 90 minus 38 in this case?
So it's 90 minus 38, so it's the cosine of 52.
52, okay, dope. On to 37.
Okay, so this is a slightly different notation than maybe you're used to seeing. 25 degrees, 43 minutes. So the cofunction is cotangent, and then it's 90 minus 25 degrees, 43 minutes. So to go up to the next minute, it's 17 minutes. That gets this to 26 degrees. Do you follow that? Or do you not remember that? That's from way in the early in the class.
Not really,
There's
actually.
60 minutes. It's a way of like doing the second part of the angle rather than doing it as a decimal. So 17 plus 43 gets you 60, and then that means you're back to 26 degrees. So when you subtract, you get whatever 64 degrees and 17 minutes.
Oh, okay.
So 64 plus 25 is 89. 43 plus 17 is 60. 60 over 60 gets you one more degree to get up to 90. These are things that people who did ships for a living, which we haven't done in, I don't know, I guess 200 years, we haven't really had ship stuff going on. So, yeah, I mean, but that's what they teach it. So you gotta know how to do it, I guess. You might ask your instructor, hey, are we going to have angles, minute problems?
Mhm. And now we are on to number 45 through 53 odd.
So 99?
45.
All right, so 45. 45 is reference angles. So so the angle is 98 degrees. And if you wanted to graph this, I think that might be useful here. 90 degrees is here, so it's right there. So it's just a little bit past. The reference angle is the shortest, is the smallest positive angle that's made with the x-axis. So it's actually this one right here. So if you go all the way around, that's 180. And if you back it off some amount, which we're trying to figure out, you'll get to 98. So if you back it off 82 degrees, that's the reference angle here.
Oh, okay.
So in a better picture here, it's like saying this is 98, this is 82. 82 is the reference angle because it's the smaller angle made with the x-axis. Because the 98 makes an angle with the x-axis, but it's too big. There are rules by quadrant, but they are very confusing. It's very easy to mess them up. So that's why I like drawing the picture with these rather than giving you a rule, because it's a different rule if it's a negative angle, which I guess there are a couple there. Are we going by odd? So 47?
Yes, and up to 53.
47 is 230 degrees. So we draw our circle here. There's 90, there's 180, there's 270. So it's somewhere in here. That's 230. So it's too far. So how far to go back? Well, 230 minus 180 equals 50 degrees. So 50 degrees here is your reference angle. It's the shortest positive, it's the smallest positive angle made with the x-axis. Maybe I'll even type that in here if I can remember. There it is. All right, 49 minus 135 degrees. This one is working the unit circle in the other direction. So here's 0, here's minus 90, here's minus 180. So it's somewhere over here, okay, is minus 135 degrees. And this is where the rules can get confusing because, yeah, you're going negative here, but it's a positive angle. So you actually have to go the other way. So you can figure out what the negative angle is, or just figure out what you have to get to negative 180, which is negative 45 degrees. But if you go negative 45 this way, clockwise, counterclockwise is just the negative of that. So that's 45 degrees is your reference angle. It's always positive, never negative. Right. 51 is 750 degrees. Okay, so this is a spiral because if you go all the way around, that's 360. Now notice when I go all the way around, I leave a little gap there, so that's 360. If you go all the way around again, that's 720. So this 50 is really like 30 degrees past this. So you might even want to redraw it here if you want, because you go all the way around and then you got 30 degrees here. So if I keep going, it's like that. So you go all the way around once, all the way around twice, that's 720, and then 30 more. You want the smallest possible, smallest positive reference angle. When it's in the first quadrant, it is just whatever that angle is. So in this case, it's 30 degrees because that is the angle in the first quadrant.
Oh, okay. Makes sense.
Because you want to go back, it's 30 degrees. Okay. 53, 4 pi over 3.
Yes.
All right. So this is where whatever the pi's get thrown in, just everyone goes crazy. Here's 0. Here's pi over 2. Here's pi over here, but I change it to 3 pi over pi because it helps to figure out where we're at. Because pi doesn't really work out well with 4 pi over 3. This is pi over 2, but if you use the same denominator, it's 1.5 pi over 3. This is 3 pi over 2, but if you just keep going like 0, 1.53, this is 4.5 pi over 3.
Oh, okay. I think I remember this.
Okay, so now that tells you where the 4 is. I'm just looking for the top number. Oh, it's down here somewhere. It's right there. There's 4 pi over 3. Great. It's also in your unit circle too, so you don't have to guess that much. We need this angle back here. So we went past 3 pi over 3. When you go past something, it's like saying, oh, I drove 20 miles, but it was 18 miles. How far back do I have to go? Well, you subtract. 4 pi over 3 minus 3 pi over 3 is pi over 3. And that's your reference angle. Awesome. I apologize. Did you say 55?
We won't be going up to 55. Now we're going to switch on over to 59 through 63, and then we'll finish off at 69.
59 through 63, all or odd?
This one will just be odd.
All right, so 59. All right, it says 300 degrees. Now you have a unit circle, but I'll try to explain this without. I'll try to explain what they want you to do without a unit circle. So there's 0, there's 90, there's 180, there's 270. So you go all the way around. Okay, and that's your 300 degrees. So you have to figure out the reference angle here. So the reference angle is this angle right here that's made with the x-axis. So how can you get to 300 degrees going the other way, or what do you need to add to get back to 360? The answer is 60. So the reference angle is 60 degrees. So why is that important? And that's because they want you to find the 6 trigonometric functions. So the angle you're given is 300. So the sine of your angle, which in this case is the sine of 300, is equal to plus or minus sine of the reference angle. So maybe this isn't any clearer or simpler, but we know that the reference angle is 60, so it's plus or minus the sine of 60. So to figure out whether it's positive or negative, you have to know which quadrant you're in. You're in quadrant 4. And you know that all students take calculus, which means that the sine of 300 is equal to the sine of 60. And because we're in quadrant 4, sine is negative there, so this is negative. Was any of that clear?
Wait, so cosine is positive and sine is negative, so that's why we go to quadrant 4, right?
You go to quadrant 4 because of the fact that this angle is in there. Like you figured out where it is, and you know that sine is negative in quadrant 4.
Okay, that makes sense.
So then you're supposed to know what the sine of 60 is. Like that's supposed to be like, I know it. Now whether that's true or not, I mean, I can't answer that either. The truth is these are all in your unit circles, so I mean, it's kind of interesting that you would ask this. So cosine of 300 is equal to the cosine of 60. It's always the reference angle, but then it's positive or negative based on which quadrant you're in. Well, you're in quadrant 4, so cosine is positive. The cosine of 60 is 1/2. So from here, you can actually just you can just carry out on your calculations, because the tangent of 60 is the ratio of these. It's minus square root of 3 over 2 over 1/2, which becomes minus square root of 3. The cosecant of 60 is the reciprocal of sine. So it's going to be the negative 2 over square root of 3. It equals the negative 2 square root of 3 over 3. And I should be clear, you're actually finding the cosecant of 300, which is the negative cosecant of 60. And we got to do the same thing for secant.
Oh, okay.
So we're trying to find the secant of 300. That is like finding the secant of 60. We know that cosine is positive, so secant is positive. It's the reciprocal of cosine, so it's 2 over 1 or just 2. Cotangent of 300, just filling in some stuff. The cotangent of 300 is related to the tangent. It's the same as the tangent of 60, and it's the same sign. So it's actually it's negative here too. I didn't. So it's negative of that. So
it's a pretty layered.
It's very layered. I mean, this is like, if you didn't have a cheat sheet, you didn't have the unit circle, it's really a good question because you have to know all these things. But we tend to have them, so it's kind of like why are we doing this? I don't know. I don't get into that anymore. I mean, that's between you and your instructor. So that's 1 over square root of 3. So it's square root of 3 over 3.
All right, cosecant.
The whole idea, though, is you bring the angle back to the first quadrant, and then you know whether you know the first quadrant values, so you can easily find, possibly find those values without looking them up in the table.
Alrighty.
All right, so I guess we have more to do here on these. These are not short.
So cosine is 1/2, and what's the sign for that one?
Of this?
Yeah.
Sine is negative square root of 3 over 2. Cosine is 1/2.
Perfect. All right. On the number 61. Yeah, 61.
61. All right, so you have to find, for example, the sine of 405. So where is that, or what's the reference angle at?
405, 405. Does it go into quadrant 4?
It goes past quadrant 4.
It goes past quadrant 4 into quadrant 1. Quad 1. So it does. Yeah, it'll be 45 degrees. Into, I think.
So it does. So it goes all the way around, and then it goes 45. So that's 45 degrees as your reference angle.
Okay.
So the sine of 405 is like 405 is like finding the sine of 45. Now this one's not great because it's in the first quadrant, so everything is positive in the first quadrant. So everything's positive. So the sine of 45 is the square root of 2 over 2. The cosine of 405 is like finding the cosine of 45 because that's its reference angle in the first quadrant, and it too is positive, so it's the square root of 2 over 2.
Oh, all right.
The tangent of 45 is the ratio of the two.
Put them over each other, and I just turn into 1?
Yep. So see if you can find the other ones.
Okay. So it's cosecant and secant, and then cotangent. Which one goes with which? Does sine go with cosecant or secant?
So sine is related to cosecant.
Sine is to cosecant? Okay. So then that one will be 2 root 2 over 2, and that's just root 2.
Yep. So it's root 2 secant.
Is it root 2 for secant?
It is. They're 2? The same. Yeah.
It's just root 2. I just wrote it as 2. Root 2. And it's just 1 for cotangent because there's no way to really flip 1. It just stays the same. All right. And on to number 63. And then we finish this one off with 69.
You said we do have to do 63. I'm sorry, I
Yeah.
didn't catch that. Okay, so 63. Um, so 63 is on the unit circle, but sine 11 pi over 6. If you see that on the unit circle, it's in quadrant 4. So it's like going all the way around right here. That's 11 pi over 6. It's kind of like the Pac-Man. The reference angle is pi over 6. So instead of finding the sine of 11 pi over 6, this one does have some structure to it. It's like the sine of pi over 6, but it's plus or minus. So which is it? Well, all students take calculus. Cosine is positive in the fourth quadrant, but sine is negative. So now you have the sine of 11 pi over 6 is 1/2, so this is negative 1/2.
Oh, okay. Now on the cosine should be, what should cosine be?
The cosine is going to be, so it's the same issue here. It's 11 pi over 6. So it's the cosine of pi over 6, but it's positive. So it's square root of 3 over 2.
At 1/2. All right. For the first one, then cosine equals, is that negative root 3 over 2?
It's positive. You're positive in this quadrant.
Okay, over 2. All right. Now tangent, put 1 over the other.
So after you get sine and cosine, you don't have to keep going through the positives and negatives. You've got your two, root ones there. So it's negative 1/2 over root 3 over 2.
That's just like, wait, chairs in the root 3 over 3?
Yep.
Okay. Negative root 3 over 3. All right. All right, now on to cosecant, and then secant, and then cotangent.
So cosecant here, it's the reciprocal of the sine.
Should be
So,
negative 2,
so you're
right?
supposed to be, you're supposed to be writing 11 pi over 6, but it comes down to this, and it becomes, it's negative. So it ends up being negative 2.
All right, and then
It's the flip of that. And then secant pi over 6 is the reciprocal of that. So it's 2 over square root of 3, which becomes 2 square root of 3 over 3.
2 square root 3 over 3. All right. Cotangent, you could try flip num, but you have to do it again. It's just, let it come back to 3 root 3 over 3.
It does reduce to just negative root 3.
Negative 3? Oh, okay. All right. Last one, 69.
69. So let me get the problem here pulled up. So this is a calculator problem. Just punch that on your calculator. Or did you mean 65? I'm sorry.
Oh, no, you're right. It's 69.
So let me get you a number here just to check. You want to make sure your calculator is in degrees.
Of course.
It's very easy to
Forget.
Well, yeah, I mean, especially if you're like taking physics, you can really mess this one up. 0.5095, so on.
That should be it for this homework. I'm going to send you the pictures for the next one.
All right, I'll stand by and wait for that.
trying to use Genius Scan for this one because the Wi-Fi cut out on my phone, but it's taking a while for some reason to send it. All right, it's sent. Should come in. Should come in any moment.
All right, checking back here. See what I see. Yeah, Zoom seems to be in a weird. Okay, that's why. All right, got some more pictures coming in. Oh, PDF this time. Great. Yeah, where do you want to start on this?
Number 3 through 12.
Okay, I'm gonna grab the picture of it. Number three is a triangle. It says solve each right triangle. Okay, those are sometimes confusing. All right, we got it here. So what this means when it says to solve?
Mm-hmm.
So you're able to do what I like to do, and this is my preference, is I make a list of the M and P for the angles, and then for the sides, little m is down here. It's across from big N, little p. And I like to make a little table. It also makes it really convenient for grading.
Okay.
So the values we already have, 124, angle P is 90.
Yeah.
So the other angle, so we do have angle N, it's 51.2. To find angle M, you're just subtracting it from 90.
Oh, okay.
So that's 48.8. No, that's 38.8. And the rest is more complicated, so I want to get to that.
Alrighty. Good point.
Okay, so let's just say we want to find n, little n. We know that the sine of 51.2 degrees, the sine of 51.2 degrees is little n over little p. But we don't know either of those, so that's bad. How about the cosine of 51.2? Well, that's 124 over p. Well, that's good if we want to find p, but not good if we want to find n. So what's the last trig function we usually use? Is tangent. Tangent of 51.2, that's n over 124, opposite over adjacent. So you can solve for n. So n is equal to 124 times the tangent of 51.2.
Oh, okay.
So you want to grab your calculator. This one's pretty intensive with calculations.
51.2. Okay.
So that's 154.2. Not degrees, just 154.2.
54. Okay. Do we plug that in?
That is n. That is n.
Okay. So now we look for P.
So P, again, you have some options here. There's actually two options. Most students go for, why did I put degree?
Go
It's not
for
degrees.
Pythagorean theorem.
Yeah, and the more advanced you get, the more you do math, the more you realize that's no good. You would just use one of these other relationships.
Yeah, different methods.
Yeah, like I would tell you to use, well, this one's preferred because P is equal to 124 divided by the cosine of 51.2. The reason this one's preferred is that um, is that you're using the given information, so you're less likely to make a mistake with the calculations because of that.
Okay, understandable.
I could give you a great lesson on this, but we've got to get through these problems. Unfortunately, like it's the way it's got to go. Oh, and we got to put units here too. These are meters. I usually forget that.
Is that 192.9? Or is that 197?
Yes. Yeah, 197.9.
197.9, okay. Put meters. Do I put degrees next to the big M?
Yes. Yep. These all should have degrees.
All right, on to number 4.
So number 4, these do go faster. You just the first one I spent a little more time trying to explain the why. Hopefully that would help you be able to do some of these on your own. But you essentially set up a table like I just mentioned here, and x, y, and z. So x is 47.8 degrees, z is 90 degrees. You can find the third by subtracting, so that's 42.2 degrees. And then little x, little y, and little z. And little z is 89.6 centimeters. So again, we have some options here, but it's all about sine, cosine, and tangent. So to find, we're going to find y first. So cosine of 47.8 is equal to y over 89.6.
Okay.
So y is equal to 89.6 times cosine of 47.8.
Oh, okay. I see how you set that up. I put my calculator. I don't know what happened to it.
Do you have an answer here?
I couldn't put it in a calculator. I'll look for it later.
Okay, I'm grabbing mine here. So I got 60.2 centimeters. That goes back of the table. So now to find x, the sine of 47.8 is equal to x over 89.6. So to solve for x, it's the same thing. You move that over to the other side. X is 89.6 sine 47.8.
Right.
If you use the wrong trig function, you will either see that you got the wrong value, like the values don't work out because you don't have them. It's kind of intuitive once you get going on a few of these. So 66.4.
So you would want to have your calculator in degree mode, right?
Yes, absolutely. Absolutely.
Just making sure.
Where are we going from here?
All right, keep on going just through 12.
5. Okay, so we're going. I want to switch to 11, if that's okay, and do 11 and 12.
Oh, perfectly fine with me.
Okay. And we'll come back to those if we have time.
That was good.
So this is more common, and it does get harder than this. I think one of the problems is you don't really have any sense of like, oh, like are these supposed to be easy? Yes, these are. These actually are, because there's much more complicated trigonometry having to do with non-right triangles, which they're not giving you here. So this is triangle A, which is 28. C is 17.4. They tell you in the problem that C is 90. So I'm going to draw it this way.
Okay.
So there's C, and I'm going to make that A, and that's B, and that's 28, and a little c is 17.4. I'm still going to make a table, but the key is you got to be able to draw. The triangle. So, and then little a, little b, little c. Little a is always across from big A. Little b is always across from big B.
Okay.
So 90. So B is 62 degrees. Just subtracting it from 90. Little c is 17.4. So we're interested. I'm just going to pick A first. A is across from the 28. So sine of 28 equals A, which is the opposite over the hypotenuse, which is 17.4. So A is equal to 17.4 sine of 28. Oh, you're waiting on me to do that. I keep thinking. All right, so 17.4 times sine d 28, 8.2. So that's 8.2.
All right.
The cosine of 28 is B over 17.4. So B is 17.4 cosine of 28. So that's 15.4. B is 15.4
meters, right?
Yeah, whatever the units are on that.
All right.
All right, so I'm going to go to 12 next. So there's a very clear distinction. I think I mentioned this in geometry between questions where you have the picture given and then questions where you don't. This is an example of where you don't have the pictures, so you have to be really careful to make sure you draw it correctly. I would recommend drawing your right triangles the same every time, same orientation. They tell you that C is 90, which I guess helps quite a bit, and that's 29.7. So again, make your table over here, A, B, C, little a, little b, little c. Big A is not given. Big B is 46. Big C is 90. So that's 44 degrees. Okay. Little c is 29.7. Little a is across from big A. Little b is across from big B. So relative to the given angle, A is adjacent to it. So adjacent means cosine to me. Cosine 46 equals A, because it's adjacent, over 29.7. So we got A equals 29.7 cosine 46. That is 20.6. The sine of 46 degrees is equal to B over 29.7. So B is equal to 29.7 times sine of 46. You should be noticing kind of a repetition here where all I'm changing is the sine and the cosine. That is going to happen when you do these problems. That's 21.4. And that goes back in the table there.
Sounds good.
All right, so let's go back. You said 5. Oh no, I did 3. Were you supposed to do 2? One. Let me look here. Oh, I did 3, 4. Okay, so we're up to 5.
I think so.
I think so.
Yeah, 3, 4, now 5.
Okay.
Yeah.
Okay. Okay, I'm going to just do the same thing. A, B, C, angles first. So big A is not given. Big B is 42.0892. Big C is 90. So this is 47.9108 degrees. Just subtracting from 90. All right, and then little b is across from big B, so that's 56.851 centimeters. All right, so I guess this one's a little more complicated because it's nice when you're given the hypotenuse. The hypotenuse is ideal. We talked about that in physics, projectile motion. When you have the hypotenuse, you can write your velocities as like the hypotenuse, cosine the angle, sine the angle. Here you have to be a little more creative. So we want to find A. A is adjacent. The given side is opposite. So tangent's the one that comes to mind. Tangent of 42.0892 equals 56.851 over little a. So I really emphasize this in my STST prep class stuff is like you can just swap the positions of these two. You don't have to multiply by a and then divide. You have to see that they just switch positions.
Oh, okay.
So a equals 56.851 divided by tangent of 42.0892. And I am putting that into the calculator. All right, so that's 62.9. Oh, it goes out more decimals. So we got 62.9421. I guess that goes out 942. All right, great. So we got A.
Mm-hmm.
So you have options for C. I always like to use the given values. So you've got the opposite and the hypotenuse. That's sine. Sine of 42.0892 equals 56.851 over little c. So again, that c can just swap positions with diagonally. And same thing over here. Like you could swap positions with that, but then you get 1 over c. And that's not what you want. So c is 56.851 over sine 42.0892. Let's get that number. Get my calculator going. 84. So C is 84.816. And this one is 62.9421. Okay, we have time for one more. These are all the same. Well, and I say that. Actually, we do need to do a 7, 8, 9, 10. So let me pick 8.
Mm-hmm.
I should have done one of these instead of the other one, but I didn't realize. I thought they were all the same. Like how many of the same ones can they give you? Okay, a lot. All right. So the only thing you can do here, well, I shouldn't say it that way. It because you've got 2 of the 3 sides, it's typical to find the other side here using Pythagorean theorem. Like normally we start out with angles, but you only know one of the angles. You only know that C is 90. But little a, well, a squared plus 6.9 squared equals 12 squared. You can solve for a using your calculator for that. So I'll do that for you. That's the square root of 144, 12 squared, minus 6.9 squared, and that's 9.8. So little a is equal to 9.8. Little b is across from big B, that's 6.9, and little c is 12. All right, so this is the challenge here. How do you find an angle? Well, we want to find, let's say we want to find a. We can use any trig function we want, but the cosine of a is the adjacent 6.9 over the hypotenuse. So do you recall from class how to undo cosine?
Undo cosine? I
Yeah.
don't remember that.
It's the arc cosine or cosine. It's not inverse, but it's often said that it's arc cosine of that. So your calculator has that feature. It has a secant, and then above cosine, you get it. So this is why you definitely want to grab your calculator to try this. This ends up being 54.9. Once you have one of the angles, you can get the other pretty easily. It's 35.1 degrees. All right, let me do one more here. I'll do 9 real quick. Actually, let me do 10 because I don't think you get 10. The back of your book. We get a lot done, but I'm sure some of this feels rushed, and this is not the best way. But so C here is the hypotenuse. It's not given. It's a right triangle, so we can find it. 85.6 squared plus 125 squared equals C squared. So you can use your calculator. You can solve for C. We need it. We need it to find the angle. So C is the square root of 85.6 squared plus 125 squared square rooted. So that C is 151.5. Okay, great. We got that number down. So let's say we're interested in finding A. The tangent of A is opposite over adjacent. It's 125 over 85.6. But that's not A. A, you have to get from undoing tangent. You undo tangent with tangent inverse. Now, if we had more time, I would have you find A using cosine inverse or arc cosine, arc sine, and arc tangent. We don't have that time tonight, but they all give you the same thing, and that's why I wanted to mention it that way. So if I go to my calculator and I punch this in, I end up getting 55.6 degrees for A. And then B is 34.4 degrees, just 90 minus that. Okay, Jack, that's all we got for now. Thanks again for scheduling, and I hope this helped. I guess you got a few left. I'll send you the notes. I'll send you the notes and the screen recordings here shortly.
Thank you. I appreciate it, Matthew. Have a nice day.
Have a good night. Bye now.
Good night.